Hello and welcome everyone to our webinar. Today we shall be discussing a very important topic, which is the AC coupling with Fronius and Victron. And as the title implies, it's going to be a joint webinar, of course, comprising of Fronius team and the Victron team. So as you can see, it's going to be a star-studded presentation team from Fronius and Victron. And I will be starting my introduction from both extreme sides. So starting from the left-hand side, of course, myself, Cyprian Okolo, the Technical Sales Advisor for Western Africa. Of course, along with my colleague, Mohammed Sidat, who is the Technical Sales Advisor for the Southern African region. And then starting from the other extreme, for the Victron team, we have Andre Durand. He is the Area Sales Manager for Southern Africa region. And then we have Clement Julien, who is the Area Sales Manager for Western and French-speaking Africa. And then, of course, we have my very good friend, David Alsina. He is the Area Sales Manager for Eastern Africa, Nigeria, Pakistan, and Israel. David Alsina, I understand, will be supporting us with the chat function, as in terms of answering your questions during the presentation. Great. So let's proceed to what we have for you today on the agenda. So, of course, as we could notice, it's going to comprise of two parts. The first part will be the Fronius part, and that will be presented by myself and Mohammed Sidat. So we shall be covering the first part of the agenda, which is answering the question, what the Fronius microgrid solution is, how it looks like, how it functions. We'll go through data manager communication interface, zero feeding, data communication and visualization, design rules, product registration, and references. So afterwards, we'd have Andre Durand and Clement continue with the Victron part of the presentation. So without further ado, let's now delve into the presentation itself. And to answer what the question is, what the Fronius microgrid solution is, we would have to look through the reasons or the situations that actually made this a necessity. So first off, we have the rising demand of electricity, which is actually a worldwide scenario. And then being the fact that fossil fuels still serves as the basis for existing microgrids, and which are commonly run by diesel gen sets. And then we have an economic angle of it with the rising prices for diesel and long distances that have to be traveled for fuel transportation. And then, of course, the need for backup because of common national blackouts and lack of electrification infrastructure. And then a very, very pertinent reason here, as would also be noticed, is that the prices of the PV components actually on a decline, which makes it a very, very real and good business case, especially in regions of high irradiation. And giving us more reasons, here is a global map of representing access to electricity. And as we can see, most of South America, North America, and Europe well above the 90% or tending towards the 100% access to electricity. But then if we look closely, much of the African region leaves much to be desired. So, and being a sub-Saharan Africa based webinar, we want to look at how this challenge can, of course, be overcome with the solution we shall be presenting you with in this webinar. And then having a closer look at the situation in Africa with this illustration, with this graphical representation, we have a chart representing percentage of the grid reliability connected to household. So the orange color represents the percentage of population that never have a reliable grid connection. The red represents those that have it occasionally, and then the yellow represents those that have it most of the time or always. And as you can see, of course, there's much to be desired across the whole of the countries represented here. But then, having said that, as gloomy as it may seem, it also behoves us to say here that Africa is actually an emerging market. That's looking at it from the positive point of view. It has there's a high growth rate, and of course high potential with its high irradiance value. And then of course the general quest to save fuel and money, and then of course ensure uptime of energy supply. This of course all intended to raise and reach their respective independency. So this of course gives rise to the solution that we provide. This includes microgrid, off-grid and backup solutions, which includes the microgrid, and of course the PV genset solution that Fronius provides. But of course today we shall be discussing the perfect match, the Fronius and Victron Energy for off-grid purpose. So that of course is a topic of discussion today. And then now let's have a look at how the Fronius and Victron system look like. So in order to better explain it, we shall be starting from answering the question of DC and AC coupling or AC coupled systems, and how they look like and how they function. So let's start with the DC coupled system. So this is basically a setup that is very, very easy to know, and I believe that most installers are conversant with, especially in regions of unstable grid. Yeah, so this is a DC coupled system which has the PV generator, or the module as you call it, connected to the charge controller, which is connected to the battery, and then connected to the inverter, the Victron inverter, and of course the inverter of course inverts the DC power to AC, which now is supplied to the load. So this is basically DC coupling and how it looks like. And then talking about AC coupling, this is how it looks like. So in this case, the PV inverter comes in, which in this case is the Fronius inverter. So with the Fronius inverter, it is possible to actually supply the load line directly from the PV generator. But then, of course, as you can see, it is coupled on the AC line to the Victron inverter. And then this makes it possible for the battery to be charged via the Victron inverter. Of course, there's a possibility of having the grid connected, and of course the genset also connected to the Victron inverter. The Victron inverter in this case is the Quatro inverter, the Victron Quatro inverter. So of course we know that in most cases the grid is usually unstable, and this might not be always available. So this makes the AC coupling the sure point to go to when it comes to increasing the efficiency when it comes to having uninterrupted power supply or efficient power supply. For those, for installers that are seeing this for the first time, I'll just take a step back. As you can see in this case, what the PV inverter does, or the best way for you to recognize an AC coupled system, is that the MPT charge controller here is replaced by the Fronius inverter. So making it possible to invert the DC and supply the load directly. So going forward, we now have what we call the AC-DC coupling. So what does that imply? It implies basically merging the best of both worlds, both the AC and the DC, because the DC has high efficiency in terms of when it comes to battery charging and supply of power, especially during nighttime when there isn't any PV generation. And then of course, the AC coupling or the AC coupled system comes in with high efficiency in power supply to the load point, especially during the daytime. I will be shedding more light on this in the subsequent slide, but this is basically how an AC-DC coupled system looks like. Another advantage that this comes with is in the event of grid outage, unavailability of the genset, and then when your battery is low. So with that, and if there's no irradiance, of course, this system is going to collapse per se. But then once it's morning time or once there's irradiance, this system can't actually pick up unless we have a portion of the PV generator that is connected through this MPPT charge controller. This now charges the battery up to its threshold voltage, and then we can now have power back into the system. Because one thing to note here is that the PV inverter, like the name implies, or is also called the grid inverter, actually depends on the grid to function, meaning that it uses the grid as its control voltage, while the Victron inverter uses the DC voltage as its control signal or control voltage. Of course, my Victron colleagues will be shedding more light on this. So continuing, you might want to ask the question, which is preferable, AC or DC? Well, I would say we derive the best from both worlds, like I said earlier. So we'll be giving us some features of AC coupling and some features of DC coupling, and then seeing the reason why it is best to combine both. So for AC coupling, majority of energy consumption is during the day. Of course, it has high efficiency during daytime of approximately 98% in supplying the load line. But then, of course, it is less efficient in charging the batteries. This is essentially because there has to be two conversion process to be done, or that goes on before the battery is charged. So we have the PV power coming from the PV generator or the module. It will first of all have to pass through the PV inverter, and then pass through the Victron inverter. This represents the Fronius inverter. It passes through the Victron inverter before it gets to the battery. So all these conversion processes tends to reduce the efficiency. Then taking a look at the DC coupling, majority of the energy is stored in the battery for use later, which is a very, very wonderful advantage. And then we now have high efficiency at charging batteries of approximately 99%. This is, of course, because there's just one step conversion process in charging the battery, meaning that from the PV generator, it just passes through the MPPT charge controller and then straight down to the battery. But in terms of supplying the load line, it will have to pass through two conversion processes, which is that of the MPPT and then that of the inverter before it gets to the load line. So I guess this explains why it's best to have both AC and DC coupled system. So let's now take a look at the Fronius connection, AC in or AC out. So this comes in very as an important point of note to ensure that we have the installation done correctly. So for AC in, if the connection is done on the AC in input part, that is if the Fronius inverter is connected to the input part of the Victron inverter, the factor 1 rule is not taken into account, but then note that the system will collapse if the grid goes out, because it is a grid-tied inverter. So if the grid goes out, the whole system goes out. But then if it is connected to the output of the Victron inverter, of course, has an output of the AC voltage, 230, 240. And this, of course, serves as the control signal for the PV inverter, the Fronius inverter. So it sees it as the grid and then uses it to function. Like I said, the PV inverter or the Fronius inverter uses AC as its control voltage. So just for you installers to note this. And yeah, so just shedding more light on the AC out. So application of the factor 1 rule comes into play. My colleagues will be discussing more on that. The inverter runs in a case of grid outage, which I've explained earlier. And of course, we'll have the opportunity to enjoy the interaction and the system control that comes with the combination of Victron and Fronius microgrid solution. So let's now take a look at how the solution works. So let's have this scenario of just to check or to see how this interaction ensures optimal operation of the system. We have a case of high irradiation, and of course, this irradiation yields to great or high power generated from the PV generator. And then this, of course, is passed through from the PV inverter, the Fronius inverter, which inverts the DC to AC, supplies the load line, and then also supplies the battery via the Victron inverter, of course. So yeah, so as you can see in this case, once the load line has been supplied with its needed energy, the rest is used to charge the battery. Then in the case of, say, maybe evening time or overcast, or maybe little or no irradiation, the same thing happens. Whatever comes from the PV is directed towards the load. But then if this is low, with respect to what is needed on the load side, it means that the energy would have to be drawn from the battery to supplement what we have coming from the PV line or the PV inverter line, as you can see. So what then happens when the battery is fully charged? When the battery is fully charged, it is important that the battery is not overcharged. This tends to be the case for other systems that don't have a good BMS, that is battery management system. But this is not the case when it comes to the Fronius Victron combo, because they have a line of communication that ensures that the battery is optimally charged and not overcharged. How does it do this? It does this by basically just going through this illustration. Even at high irradiation and high power being generated from the PV generator, the PV inverter just supplies exactly what is needed from the load side, and then ensures that the battery isn't overcharged. And how does it do this? The Victron inverter, of course, sends a signal to the Fronius inverter via this same load line, this same AC coupled load line, and then that ensures that the PV inverter reduces its power output to ensure that the load gets supplied what it needs, and then the battery isn't, the charging of the battery stops. So the process, or how we're able to achieve this, is by what we call the frequency controlled power reduction. So frequency controlled power reduction means that the frequency is used as a signal which is sent by the Victron inverter to the Fronius inverter via the AC line. So once the Fronius inverter senses or sees this signal, or that is the increase in frequency, it automatically reduces its feed-in power. So we're going to see that from this illustration. As you can see, that as the state of charge of the battery crosses 90% and tending towards 100, the same happens here. As you can see, the battery charge reduces with, of course, the increase in frequency. This increase in frequency is, of course, generated by the Victron inverter. So it sends the signal to the Fronius inverter, and then this, of course, leads to the decrease in feed-in power to the battery and subsequent stoppage of charge, of course, when the battery is full. So, yes, so this is, of course, achievable with our Fronius inverters, ranging from the residential to the commercial. For the residential, we have the single and three-phase, ranging from the Primo 3.0 to 8.2, and then, of course, the Simo 3.0 to 8.2. That is for the residential. And for the commercial, we have the Simo 10 to 20 kilowatts, and then, of course, the Echo 25 and 27 kilowatts. All these have been successfully tested and fully compatible with the Victron Quatro and Victron Multiplus to ensure that we have the best of both worlds. Great, so now let's look at how to successfully set up the system. Basically, there are 4 easy steps. Of course, we have to start up. Of course, it can take any of these orders, but then we'd have installation of the PV generator, carry out the cabling, commission it, and then, of course, we'll have to set up the Victron system using the Victron configuration process. Of course, set up your battery, go through the commissioning process, set up the AC coupling line, do the VE bus configuration, and complete the wizards. All these will be emphasized upon by my Victron colleagues for this presentation. And then on the Fronius side, of course, being supplied by AC from the Victron, would now have to do the commissioning, of course, ensuring that you have chosen the microgrid setup, which I will be explaining in the subsequent slide. Yes, so for the settings that has to be done on the Fronius side, there is a special country setup that would have to be enabled in order for both systems or both inverters to communicate effectively. That is what we call this, the setup MG50 or MG60. 50 and 60 represents the operational frequency of the particular region that the system is being installed in. If it is 50 Hz, then you use MG50. If it is 60 Hz, then you use MG60. So this, of course, ensures that we have seamless line of communication. And then, of course, there is a possibility of extended voltage and frequency limits to ensure that the system communicates seamlessly. Of course, this is fully configurable. And then how do you now choose this MG50 or 60? Please, all you need to do is to tap this button on the display unit of the snap inverter, the second from the right, as you can see. If you tap it 5 times, you would have all these digits in zeros. So all you need to do is to use the plus, minus, and enter button to input 73887. Once you do that, that is the access code or the access code for the country setup. Once that is done, you can now scroll and select MG50. I must say here that in some cases, I've had cases where the system didn't function properly because installers chose the normal 50 Hz. Please ensure that you choose MG50 or MG60. This will ensure that you have selected the proper code for the its function as in an AC coupled system in a Fronius Victron combo. Great. So once you have confirmed this, you can now reboot and then the system is set to go. Good. So how to connect the inverter? Basically, you'd have to activate the Wi-Fi access point on the inverter display. This is, of course, covered in a dedicated webinar that we have made for this purpose. So you can go through our YouTube channel to have more info on how to do that. Then next, you now have to connect to any smart device in the internet, in the inverter network, of course. Open the browser and then impute this IP address, 192.168.250.181. This, of course, automatically opens up the setup wizard, and then you can now successfully connect your inverter to the system. If there are multiple inverters in the system, please ensure that you have just one master in the SolarNet ring. I will tell us more on that in the next slide. So this is basically how it looks like for cases where you have multiple inverters. Please ensure that you use your Ethernet and RJ45 terminal to interconnect all the inverters from the out of the first inverter to the in of the next inverter and then out, because each of the inverter has 2 ports, RJ45 ports that can be used to set up a SolarNet ring. So once this is done, please ensure that only one data manager is turned on. If there are other inverters that has the data manager, please ensure that they're all in the off position, what we call the master and slave position. So the master is the on position and the slave is the off position. Please ensure that this is done to ensure seamless communication, data communication between the Fronius inverters. Great. So this brings me to the end of my part for this presentation. Mohammed Sidat will be continuing from this point. So I will be handing over presenter rights to Mohammed. So Mohammed, you can take over from here. Thank you.
Thank you very much, Cyprian. Okay, we will now move on to the next part of the Fronius presentation, where we will now be looking at your data manager communication interface. As my colleague Cyprian did make mention, it is compulsory to have at least one Fronius inverter with an integrated data manager. Please do note any Fronius inverters that are bigger than 8.2 kilowatts, the data manager will come as an additional optional extra. Okay, any inverter smaller than 8.2 kilowatts, the inverter does come already with an integrated data manager. So please do take note of that, and please be aware when you are ordering your inverters from your distributor. So what is the Fronius data manager? The Fronius data manager is a communication card from Fronius that is found in Fronius inverters, as I alluded to in the previous slide. This is how the card looks. It's a plug-in card that plugs directly into the Fronius inverter. So if it needs to be replaced, it can always be replaced with a new card by just putting out the old one and putting a new one in. You can also order the data manager in the box version. So if you prefer to have your communication separate from your inverter, that's also possible. Either way, whether it's going to be the card version or the box version, they are identical in functionality. So what's important to note on the data manager card is, firstly, you've got your wireless antenna. Okay, this will allow the inverter to connect to wireless networks. Then you have your orange plug over here, and this is where the inverter will do any Modbus communications on RTU. So remember, Modbus RTU is for RS485 connections. And this is also where the data manager will communicate with the Fronius smart meter, because the Fronius smart meter communicates over RS485 on Modbus RTU. This is where you can also connect, let's call it external relays from ports 0 to 3. And this is where you can also send input signals. So maybe you want to control the inverter power from port 4 to 9. Then over here, we've got your LAN connection, okay, which can be used for Modbus TCP communication, or it can also be used for your your wired connection through a router to the internet. Then on the right-hand side, we have your LEDs, and these are your status LEDs for any connections on the communication. I just want to further elaborate on the Modbus termination switch. This switch is found directly on top of the antenna. And if the switch is on the on position, it means that you are activating the 120 ohm resistor. If it's on the off position, it means that your 120 ohm resistor is deactivated. Please make sure for any Modbus RTU communication, you need to have a 120 ohm resistor at the beginning of the loop and 120 ohm resistor at the end of the loop. Another important parameter is your IP switch. It's a very small switch which is found directly on top of your LEDs. This IP switch has two positions. It has position B. Okay, position B basically means that the inverter will obtain its IP address. And position A, you're basically setting the data manager to have a predefined IP address. We will get into that a bit later on. So moving on. How can the data manager communicate over Modbus TCP? So please remember that it is important that the inverter can communicate with Victron over Modbus TCP for zero feed-in applications. If you do not do a zero feed-in application, then there is no need to set any Modbus settings. This is only needed when you cannot feed power back to the grid. The reason why this is needed is that the Victron needs to be able to address certain registers within our inverter in order to enable our inverter to throttle down its power to prevent backfeed to the grid. So there's multiple ways, or 3 ways to be precise, in order that you can achieve communication over Modbus TCP. So the first method is to set up a local area network, which is a LAN configuration. Here you set up a valid LAN IP address on the Fronius using one of the following methods. The first one is your DHCP addressing method, and this is when you use a dynamic IP address. So if you have a DHCP present, remember a DHCP means that if you have a router that can connect to the internet and that can also allocate IP addresses automatically for you, then you can connect the Fronius with a LAN cable to the same router as a Victron. It could be the Victron color control or the servo, etc. The Fronius will obtain its IP address automatically from the router. Make sure the IP switch on the Fronius data manager is in position B. The advantage of going with this approach is that it's an easy installation. You can connect multiple Fronius inverters, and Fronius has access to the internet. The disadvantage is that this might take a bit long to search for the Fronius inverter if you have a large subnet. So let's say if you're doing an installation for a commercial customer where they have a lot of devices on their DHCP server, then when the Victron is searching for the Fronius, it can take a few minutes because obviously the Victron has to go through all the different devices in the subnet until it finds the Fronius. The second method is your link local addressing method, which is your predefined IP. So when no router is present, you need to connect the data manager with the LAN cable to the LAN interface of the color control or servo. Make sure the IP switch is in position A. Then connect the Fronius and color control on the same LAN network, either with a LAN cable or network switch. Fronius will now have a predefined IP address of 169.254.0.180. The advantage is that you have a low risk of communication failing, and the advantage here is that you don't need a DHCP router. Disadvantage, Fronius does not have access to the internet, and in this sort of scenario, you can only use one master inverter. Remember, a master Fronius inverter is a Fronius inverter with a data manager. So in this case, you can use multiple Fronius inverters, but please make sure that only one of the Fronius inverters have a data manager. The third method is your what we call manual addressing method, which is your static IP. So when there is a DHCP server present, but now you want to give a specific IP address to the data manager, make sure the IP switch is in position B, make sure the subnet mask is the same as that of the color control, and make sure you set a unique IP address. Remember, with a unique IP address, your first 9 digits will be the same as what the color control is. The only difference will be in the last 3 digits. Okay. Please make sure to set the gateway and DNS for internet connectivity. The advantages, your Fronius has access to the internet. Your color control search for Fronius can be done very quickly because the color control already knows what the address for the Fronius will be. Disadvantages, it's a bit more complicated to set up. Okay, so please do take note. This Modbus TCP, whenever you're setting Modbus TCP comms between Fronius and Victron, you need to do this. But also, if you also need to make the Victron and Fronius communicate also for normal operation. So where you have an operation where you can feed into the grid, you still need to do these settings. The reason for that is that we have a communication platform with Victron called Solar API. Okay, so basically what that means is that the Victron can read our power values throughout the day, okay, through a network. Okay, and this network you can achieve using one of the 3 methods. Okay, so as I'm pointing out, it's not only for Modbus TCP, it's also for the Victron to get basic information of the Fronius inverter. And it's very important that the Victron gets that information because the Victron needs to know what the Fronius is producing in order to prevent overcharging of your battery system. Moving on to the next section, which will be zero feed-in. So when you are setting up zero feed-in on a Fronius system with Victron, there could be 2 scenarios. The first scenario is when the Fronius is connected to the output of the Victron. Okay, you can see I have put output in red because this is very important. If this is the case, then please make sure that you use the Victron ESS system for grid limiting. The only thing you then need to do on the Fronius is that you have to go to the Fronius data manager. You need to connect to the Fronius data manager. Once you're on the data manager, you need to go to settings. You then need to scroll to Modbus. Once you're on Modbus, you then need to enter these settings as shown to you on the screen. So your data export via Modbus needs to be TCP. Your Modbus port needs to be 502. Your string control address offset needs to be 101. Your sunspec model type needs to be integer plus SF. Then your inverter control via Modbus needs to be ticked. And please make sure that you set the correct priorities over here. So your control via Modbus needs to be number 1. IO control needs to be number 2. And dynamic power reduction needs to be number 3. Once you've done that, please click on the tick and you then have set up a zero feed-in system when the Fronius is on the output of the Victron. The next scenario is when the Fronius is connected on the input of the Victron. What do you do then? So in this case, you then need to use the Fronius smart meter in order to do zero feed-in for your system. If that's the case, what you then need to do is you also need to log on to the data manager. But now when you log on to the data manager, instead of going to your Modbus settings, you now go to your smart meter settings. You activate your smart meter, and once you've activated your Fronius smart meter on the data manager, you then need to go to dynamic power reduction, and you then need to tick limit for entire system. It will ask you what is the total DC power of your system. So if your total DC power is 5,000 watts, you need to enter that. And what is the maximum grid feeding power? So if you're not allowed to feed into the grid, that will be 0%. If you are allowed to feed in, let's say 20% of the system size to the grid, then you would set 20% over there. Okay, remember this refers to the Fronius side of the installation, which is your AC coupled, and does not refer to the DC coupled side of the installation. Moving on to the next section, which is your data communication and visualization. So your data communication with Fronius is via the data manager. Okay. The data manager will send all the information that it collects from a single Fronius inverter or even multiple Fronius inverters to SolarWeb, which you can then monitor in order to see what your, for example, your PV production is. Okay, remember, if you do not have a Fronius smart meter, so i.e., if your Fronius is connected to the output of the Victron, in that case, you will not have a Fronius smart meter. Then on SolarWeb, you'll only be able to see the inverter production. You will not be able to see what's going to and from the grid, and you will not be able to see your consumption. The reason for that is because the Victron system, which is connected to their smart meter, will then be able to detect that on their VRM platform. And that's why if your Fronius is on the output of the Victron, you're more than likely going to be using VRM to get a complete system overview. If your Fronius is connected to the input of the Victron, then maybe SolarWeb would be a bit more handy to see at least what's going to and from the grid. I just want to point out as well, we do have the SolarWeb app. Victron also has their VRM application as well. Okay, so how does the data manager really, communicate? So the first type of connection the data manager can have is over Modbus RTU. And for example, if your Fronius is on the input of a Victron, then you'll be connecting a Fronius smart meter to communicate over Modbus RTU with the Fronius data manager. As I said earlier on, it's very important that we do establish a Fronius TCP. So remember, the Modbus TCP communication is to set up your zero feed-in functionality. Then your JSON is to set up the API, the Solar API functionality, where the Victron can actually read the values of the Fronius. Okay, and then as I said earlier on, you can also have an Ethernet connection to a router as well. And this is how the Fronius and the Victron can communicate, is also through a router. Or you can also have a direct link between the Fronius and the Victron. So what I'm showing you is this a screenshot of what a Fronius Victron system can look like. So in this case, we have a cloud control. And here you can see we have your Fronius system, which appears. And here you can see your PV generation. You can see your AC loads. You can see your set of charge of your battery. You can also see your different phase currents, etc. Again, I am showing you a screenshot of what the VRM platform can look like. And I'm also showing you what the Fronius SolarWeb platform can look like as well. Okay, remember with the Fronius SolarWeb, it is very handy when you do want to do remote updates. So with Fronius, you can always do a remote update on your data manager and on the inverter firmware. We also offer you a premium version, but everybody in Sub-Saharan Africa gets access to the premium version for free, which basically means that you get up to 3 years of data on SolarWeb. And you can also see consumption visualization. Remember, you can only see consumption visualization if you do have a Fronius smart meter installed. And you can also see service messages. So if there is anything wrong with your Fronius inverter, you'll get a service message on SolarWeb, and you can then address that error. And you can also see your energy balances daily, monthly, or even yearly. Moving on to the next section, which is design rules. Please do ensure that you follow the following design rules when you are setting up a Victron Fronius system. The first and most important is your correct dimensioning, which is 1:1. This means that the peak power of the PV inverter must not exceed the maximum power of the inverter charge. Fronius inverters have a DC to AC ratio, DC over dimensioning, of up to 150%. However, please confirm with your datasheet, because, for example, the Fronius Eco only has an oversized compatibility of 140%, but the Fronius Simo can go up to 150%. And this again will ensure that you can, utilize the inverter for the maximum possible duration to get the maximum output as possible. The next important parameter is your microgrid setup. So as my colleague Cyprian mentioned earlier on, please make sure that you go into the 73887 menu, and please make sure you select MG50. The reason why we have a separate microgrid 50 setup is because when we are doing a microgrid setup with Victron, we need to be able to reduce our output dependent on what the frequency is on the power supply line. And remember, our power supply line will be from Victron. Okay, so if the Victron increases its frequency, the only reason it will do that is because it wants to reduce the output of the Fronius in order to prevent too much power coming in and overcharging your battery system. So the advantage of the MG50 setup is that the frequency dependent power reduction is already set for you. So you don't have to do any settings of the frequency dependent power reduction curve. And yeah, this comes standard with each and every Fronius snap inverter. It's pre-programmed. All you got to do is just select MG50. We always provide planning support. So yeah, we can always assist you with designing your system if you are looking at doing an AC coupled system. And yeah, just to remind you, we have multiple distributors throughout Sub-Saharan Africa. So I think at the moment we have over 10. And yeah, they have a full technical support team that can also assist you. And yeah, we also got your Fronius technical sales advisors that can also assist you with these type of systems. So I just want to show you an example of the one-to-one rule. So I've taken the most popular Fronius inverter in Sub-Saharan Africa, which is a Fronius Eco. It's a three-phase inverter. It's a 27 kilowatt inverter. Please do note that this inverter will give you a balanced output. Okay. And per phase, it cannot exceed about 9 kilowatts per phase. So all you have to do is take 27 kilowatts, divide it by 3, and you get 9 kilowatts per phase. That means that it is impossible for the Fronius Eco to output more than 9 kilowatts per phase. This is very important for the one-to-one rule because you now know that this inverter will give you a maximum of 9 kilowatt output per phase. And in order to obey the one-to-one rule, the closest Victron unit that's bigger than 9 kilowatts is the Quatro 10 kVA. And remember, the rule states 1 kilowatt of Fronius to 1 kVA of Quatro or less. Okay, so in this case, the Fronius is less than the Victron Quatro per phase, as you can see over here. So we got 9 kilowatt on phase 1, and the Quatro is 10 kVA. And so can be said for phase 2 and phase 3. So again, we're following the one-to-one rule for all 3 phases. Remember, the Fronius unit, in this case, the Eco is a 3-phase system, and your Victron Quattros are all single-phase systems. So in this case, you need 3 single-phase Quattros and 1 3-phase Eco. I'd like to show you some cool references we have with Victron. The first one is a system in Mali. This, I would believe, is probably one of the biggest Fronius Victron installations done to date. This installation, it was 7 different installations on the same location. So it was 7 different installations combined into one complete installation. So that's what the 7 installations means over there. So in total, the system was 520 kilowatts. According to my knowledge, as I said earlier on, it could be the biggest standalone installation to date. For each of the installations, we had about 6, for the complete installation, we had 6 Fronius Eco 27s, okay, and we had 15 Victron Quatro 15 kVAs. Okay, so you can see this was an AC coupled system. The battery was your lead acid battery, so that's the OPZ, it's lead acid. The genset, they also had a genset on site, which was a 300 kVA genset. The system was commissioned in 2014. And yeah, the characteristics, 98% met by solar and 2% met by generators. So again, there was no grid present in this installation at all. The next nice reference I have is an installation done in Laikipia, which is in Kenya. This was a combination of AC and DC coupling. So we had an 80 kilowatt AC coupled system, and we also had a 20 kilowatt DC coupled system as well. It was a commercial field installation. There were 4 Fronius Simo inverters installed. So as you can see, the Fronius Simo inverters were mounted directly underneath the modules. The reason we could do that is because, as you know, the Fronius inverters are rated as IP65. The system was commissioned in 2015. The inverter charger was a Victron Quatro. We had multiple units, as can be seen over here. We also had multiple Victron Blue Solar charge controllers that are your DC coupling. And the battery, again, was a lead acid battery. And the special feature, it was a microgrid and the 100% self-consumption. Next installation is Fronius South Africa. So again, we believe in the system so much that we actually have the system powering up our office. Okay, so this is a AC coupled system at Fronius South Africa. It's a 10.4 kilowatt system. It's got AC and DC coupling. So we've got 3 phases. Only a single phase is on backup, and the other 2 phases are grid tied. We've got a Fronius Primal single phase 8.2 kilowatt inverter, which is connected to the output of a Victron Quatro 10 kVA. And we also have a smart solar MPT 250-60 charge controller that is for your DC coupling. For the battery storage, we've got a 40 kilowatt hour lithium iron phosphate Blue Nova for the 8-volt battery. And yeah, our savings per month is about 6,000 Rand per month. And we did commission this in 2020. And the current characteristics is 85% of our power requirements met by solar and 15% is met by grid. The only time we use the grid is for phase 2 and phase 3. And that's the only reason we do that is when we are powering up 3-phase devices. So how does Fronius provide one of the best support on the market? Again, we have multiple Fronius system partners. So currently in Sub-Saharan Africa, we have almost 50 Fronius system partners. And these are well-educated professionals that have installed multiple Fronius systems and that have also attended the necessary training to be able to do board replacements, etc. We also have 3 technical sales advisors in Sub-Saharan Africa. We also got the technical support hotline as well, which you again more than welcome to contact. Yeah, why should you rely on Fronius and Victron? Again, this is the #1 choice for off-grid systems in Africa. Fronius and Victron are strengthening the partnership day-on-day basis. We do have multiple technical adaptations, which ensures smooth operation of the system. We are fully configurable. We do have a technical support commitment on both sides. Yeah, we do have a mutual support procedure, and yeah, we do host multiple training courses together. For further information on any Fronius products, you are welcome to go to our homepage. You're also welcome to go to our YouTube channel. So we've got a playlist for Sub-Saharan Africa where we have all our webinars, including today's webinar, which will also be placed on this link. Okay, I will now hand over to Andre Durand from Victron, who will now take over the latter part of this presentation. Andre, I will be handing over presenter rights to you, so yeah, please make sure you activate your microphone. Yep, perfect. Great.
Good afternoon, everyone. Thank you very much for your patience there. I will carry on with the Victron Energy part of this afternoon's presentation. And I wanted to just give everybody an update on the Victron Energy Africa sales team. So here I am with all my colleagues. On the right, we have Gerard Tromp, that looks after South Africa, David Alcina and Clement, that have been referred to earlier in the presentation. And we have Anku van der Bergheek, that lives up in West Africa, that does technical training and support for us. And we have Jan Klumpenaar, that is our head manager up in Holland that we deal with on a day-to-day basis. So today we're going to focus on some solar products for solar systems, monitoring and configuration, and then we'll go through some references, training, and community. So let's start with solar products. So the slide here, you can see today we're focusing on rural electrification off-grid. So there is no grid connected, so we won't be talking about grid connected systems and ESS and grid codes and those kind of things. We're focusing on systems that are off-grid and including a generator. So some of the behavior in these systems, what to look out for, how to solve them. So the Victron inverter chargers are used in different types of installations. I've just spoken about the ESS or energy storage market. That's where you obviously have grid. And then when the grid's totally available, we have the bad grid systems where the system is set up to do intentional islanding, where you choose to disconnect from the grid and only connect when you have certain scenarios happening, like a low battery situation or a high load demand. And the setting we use there is called the ignore AC input. The third setting is just basically a general battery backup system, usually without solar power. The inverter chargers use as a UPS. And the fourth one is the one that we refer to for today's training, off-grid, where there's no grid available, and your battery and your PV energy has to carry all the loads, power all the loads. Generators can be integrated for high power applications and for battery charging assistance. System sizing is done on worst case scenario because your battery and your PV have to carry all the loads for 24 hours. So from the inverter charger range, we are in a continuous research and development phase at the moment at Victron Energy, where we are adding more new models to our range. The top models on this slide show you all the old aluminium casing inverter chargers. The bottom is the new range that we've been developing for the last couple of years. And we are very soon going to be adding the new 15 kVA in the new Multiplus II format. Those are the ones at the bottom of the screen. That'll be coming into our range very soon as well. So yeah, there's lots happening at Victron Energy from a product development point of view. Let's just quickly talk about the Multiplus. A lot of people refer to this as the Multiplus One. For us, it's just the Multiplus. This internal wiring diagram was shown earlier in the Fronius presentation, but this product has one AC input and an inverter output that is not switchable, and then it has a second output that is switchable. So it's controlled by AC output 2 relay. So it's by default it's set to operate in a certain way. So this relay will be linked to the AC input relay. There's always a 3-minute delay for this one to close after the AC input is closed. So, for instance, the generator is connected. After 3 minutes, a timer will close this relay. You are also able to program the inverter to operate this relay under different circumstances. So take it out of default mode. So sometimes if you want to do load disconnecting, or there's various parameters for that. So some of the technical features, these are for 230 volt systems. You can see the input voltage range. The bottom range is 187. And if you are in a country where you have lots of low voltage situations on your grid and you want to connect a Multiplus or a Quatro to the grid, make sure that you program your inverter charger to only accept a higher voltage. We always say 200 volts is a safe voltage. The moment you're operating an inverter charger at around 190 volts, 195 volts, and under high current, and the moment the grid disconnects, that high current will be the responsibility of the battery inverter, and that could lead to overload and all kinds of damage. So in your programming, we always recommend to raise this voltage up to 200 volts, your disconnect level. So the models start at 500, they go up to 5 kVA, 12, 24, and 48 volt systems. So various different models. Still a stalwart in our range. We will not discontinue them. And when we will start doing that is it's not clear at this stage. We still sell many of these inverter chargers. The Quatro, the bigger brother, this was launched in around 2004. The first Quatro was brought into our range. It's already been around for a very long time, 18 years. And the only major difference is that this now has a second AC input. So you can wire another AC input source into the Quatro. So, and also they are much larger. So they go up to 15 kVA. So generally speaking, if you want to do 10, 20, 30, 40, 50, 60 kVA systems, you go for the Quatro. But sometimes when you're grid connected and you have a weak grid and you have a generator for backup, the Quatro is ideal because then you can connect both those sources directly to the input of the Quatro, and it can be managed internally. You don't need an external AC transfer switch. And the new range we've been working on for a very long time. It's already in our product range for 5 years. Is the Multiplus II. And internally, if you look at the wiring diagram, you'll see the input contacts or relays. There are now 2 in series for the live and neutral cable. And this is what we call the hardwire anti-islanding device that's built into the system. So, and that's mainly for energy storage applications on grid. But this product is proving to be very successful and reliable in off-grid applications as well. The range is now 3,000, 5,000, and goes up to 10 kVA. At the moment, the 8 and the 10 kVA are not compatible for parallel systems, but they are compatible for 3-phase. So 3-phase meaning 3 units, 1 per phase. So 3 times 10 is 30 kVA. You cannot add any parallel units at this stage. When that'll be available is also unclear at this stage. Just watch our internal, our blog communications about that. There will be a release about that in the future. So yeah, this product is becoming very successful. We're selling lots of that in the southern sub-Saharan area. Yeah, so really it's proving to be a good product. Yeah. So the next one we brought out is the Multiplus II. So the first edition was the Multiplus II GX. You can see on the front panel, there's now a 2-segment display, and that's linked to the internal GX device. So it's almost like a color control, but it's not a color control. It's a much more powerful GX device. Comes with a simple 2-segment display, all the necessary communication ports, one for your managed lithium-ion battery, only for 500 kilobits. In the next 3 to 4 months, there will be a hardware change where that CAN port for the managed battery will become a VCAN port, and you'll be able to program it for 250 kilobits per second and 500 kilobits. So that's a new hardware change to look out for. It will be a totally new inverter charger with a new product number. So just keep a lookout for that. All the other communication ports are here, V-Direct for MPTs. Like I mentioned, it's a very powerful GX device. At the moment you connect another product to this GX device, that information will be displayed on the 2-segment display. Warnings and alarms are also displayed here. And that was the idea behind this product, for standalone systems, 3 or 5 kVA, where somebody wanted a simple display with a simple readout giving you all the necessary information for the user. Okay, so the next part of the solar systems products is the MPT. My colleagues from Fronius have spoken about this already. The MPT is obviously a DC charger that's connected on the DC bus of the system. What we always look at when you're choosing a Victron Energy MPT in your system, in our training, we always talk about the installer must look at the load profile, because in the daytime, if you don't have a lot of AC demand, then the MPT's job will be to charge the batteries. And that's when it comes into its own, and is very efficient for the battery charging. You can see plus or minus 97% efficient. So in the daytime, all the excess energy will be charged into the battery as efficiently as possible. And the other benefit of this is if your system disconnects from the grid or is off grid and overnight you have a low battery shutdown, the next morning the MPT will raise the battery voltage and switch on your inverter charger. So that's a very important part of why we always install an MPT, is to prevent a total blackout for extended periods. So the MPT range, this range has grown tremendously over the last 12 years. Today I'm talking about only the smart solar MPTs. We do have other models that are non-smart, but they range from a system for 100 watt panel installation up to a 6 kilowatt peak panel installation with 1 MPT. There's wireless configuration, Bluetooth monitoring, 30-day history is available, very fast MPT tracking, and remote configuration. So you can now remotely program these MPT settings over the internet. You can update the firmware, you can change the settings, you can download the history. And a few years ago now, we launched the Smart Solar MPT RS. This is a new range for us with a 450 volt input now. There's a 100 and a 200 amp model. The 100 amp model has 2 independent PV inputs with a total of around 5.7 kilowatt peak input. Depending on the panels that you're using, you can connect more solar power to this. We recommend you use our Excel calculator sheet to customize your PV installation. The 200 amp model has 4 PV inputs, all totally isolated from each other. So it can be 4 different directions, 4 different types of solar panels. And that's around 11.5 to 2 kilowatt peak of total PV input. They have VCAN communication. So on the CAN bus, they communicate seamlessly with all the CAN devices. They have a very nice LCD display. that will give you full monitoring of each PV input, your total yield, and string information. So the range looks like this. The top range is the blue solar. Those are the ones without Bluetooth. Still very successful around the world. We brought out the Bluetooth enabled units around 2016, and since then this range has grown tremendously. My colleague Clement will talk about the Bluetooth configuration and all the settings and the benefits of that. And in the last 4 years, we brought out the new VCAN MPTs, which just makes the network connectivity for larger systems much simpler. So you can have up to 20 MPTs connected to each other with a simple RJ45 cable. Much easier to configure those larger systems. And then the 450-100 range 100 amp model is readily available in South Africa, well, in most of Africa. The 200 amp model is a little bit delayed due to some production delays. But yeah, we're having great success with these products already in lots of large projects. So the next part of the components for solar systems, of course, are the batteries. I'm only going to talk about the lithium batteries today. And here we have a snapshot of some of the batteries in our industry. The ones on the left are the Victron Energy lithium iron phosphate batteries, mainly used for 12 and 24 volt systems in automotive and marine applications. And on the right, we have the CAN bus lithium ion batteries. Here are some of the brands just to show you, and we call these the managed CAN bus batteries. A managed CAN bus battery has a BMU or BMS and an internal safety contactor, and they calculate internally the state of health, the state of charge. They monitor per cell level, the voltage, the temperature, and all of that. And depending on which managed CAN bus battery you have, that information is all sent to the GX device, and the GX device becomes the system controller, and now communicates with all the battery chargers and the inverters. And depending whether your inverter is your inverter charger is actually acting as a charger, the GX device will send the charge commands to both the MPT and the charger to compensate for what the battery wants. And a lot of these settings are linked to a feature called DVCC, distributed voltage and current control, and that dynamically allows the battery to control the charging, to ensure that all the cells are balanced and they're all working harmoniously. So that's quite critical. Lithium-ion batteries, we've learned a lot of that in the last 7-8 years. In a lot of ways, they're totally different to lead-acid batteries, but there are some they do need regular charging. So the settings are very important in that space. Okay, so a new feature that we have now, a lot of these digitally interfaced batteries, the moment you connect it to our GX devices, there's an auto detect feature. So the GX device will automatically program all the settings for the particular battery the moment you connect it to the GX device. What's important is that you need to use the right cable, connected to one of the GX devices. So depending on which battery, there's a type A or type B cable. And then you need to make the appropriate settings in the Multiplus for low voltage. You need to enable DVCC. So this enabled DVCC, depending on which lithium-ion battery, that is now automatically enabled for you. And it's actually forced on, so you cannot go and change the settings. Some of the batteries that's not active. And the DVCC is part of the digital control that the battery has over the system. So there's a lot of other lithium-ion batteries in the market that do communicate with the Victron system or the GX device, but they only send state of charge. And then our system can work with that state of charge to prevent deep discharge and maybe some shutdown settings, but there's no dynamic control on a cell level. So if you want your lithium-ion battery to last for 10 or 15 years, make sure there's cell level control from the battery to the Victron system. And that's what these digitally enabled or CAN bus batteries provide you with. So we have a very nice guideline. So it's the battery compatibility. You can just Google it, Victron battery compatibility. This page will come up with all the different guidelines and manuals for each different battery in the market. And these are all the digitally interfaced batteries. A lot of these manuals are up to date. There's maybe one or two that needs to be updated. I know the BYD one is up to date. Pylon Tech need to add, I think, one new model. Freedom 1 is up to date. So a lot of good batteries there, all working very, very well. Yeah, we have hardly any battery support issues around the world, but we are also open to working with other battery companies to get them on this list. So that's a continuous discussion that we have on an R&D level with these battery manufacturers. So I thought that would be interesting for you guys to also know about. So the next slide, I will hand you over to Clément, my colleague.
Thank you, André, and hi everybody. So now we will discuss about the monitoring and configuration of the system. So again, we are still only talking about off-grid electrification and not about ESS system with grid, so only a remote application with or without generator. So first, let's see the monitoring with the GX device. So it's used our VRM system. If you want to do it remotely and locally, you can also see through the screen the status of the system. So you will have a dashboard with the layout of the system, and you can monitor everything. And you have also the VRM portal. So on the VRM portal, it's a website, and when your installation is connected to the internet, you can remotely check what's happening on the system. So you have a dashboard. You can see in real time what's happening in the system, and you have also historical data. So you can see how your system behaves and the saving you are doing. You can also see what's happening with your generator, with your PV system. Can be both DC and AC coupling, so you will see the yield, and you can check also obviously the battery status. So this is our remote monitoring function, and we can do as well the same than Fronius. We can do the firmware update remotely. You can also change the settings remotely, how the system behaves, and so it's really convenient to use. You have also alarm and service emails. So if any alarm is generated by the system, you will be informed by email. So it's really, really convenient to use and really powerful tool. Next one. So here you have a screenshot of the dashboard. So we just launched a new dark mode last week. It's really nice to use, really beautiful. So you can see here an example of a system using both DC coupling and AC coupling system, and yeah, with just you can see everything what's happening in the system. Next one. So also we have some advanced features, so you can see the curves of the system. You can see what's happening in all the device of your system. And we just launched also last week a new feature. So it's a custom widget. It's really nice to use. So you can choose, you can pick up in the list what are the data you want to plot in the widget, and you can see it, and you can check remotely what's happening on the system. So for example, on an AC coupling system, you can plot, for example, the PV production, and you can plot in the same widget the frequency, the AC frequency. So you can see the AC frequency rising when the battery is full, and you can see as well that the PV power will reduce. So with this simple custom widget, you can check everything is happening in the system. So it's really nice. Next one, please. So to discuss more about our GX device, so we have many GX devices. There is a color control, which is the first one. But now it's what we would advise is to use the Servo GX. This one is really powerful. It's the last one on the family, and you can you can connect a lot of device to it. André, now we don't see anymore the presentation. Okay, thank you. So you can connect lithium battery on the GX device, and you have a V-direct port, so you can also connect V-direct MPPT. You can also connect VCAN MPPT. There is a programmable relays, so that we'll see we can control easily a generator, the start and stop of a generator. You can also connect temperature sensor, tank sensor, and digital inputs. So it's really powerful tool. And if you want, you can also connect an optional touch screen. So we have the 50 and the 70. So yeah, this is the preferred solution for remote monitoring and control. Next one, please. So Andre already talked about this, but you can have also the GX device built in the inverter charger. So this is the range we call the Multiplus II GX. So there is two products available. There is the 3 kVA and the 5 kVA. So you have basically the same function, but is little bit less feature than the GX. You have less port than the GX. And yeah, some feature are not supported, but it's really a nice product. It's all in one, so you can save time during installation, during wiring, and you have also the display directly on the Multiplus. So it's really a good solution for simple single-phase system. So now we'll see together how to configure the system. So we have an application, a software called Victron Connect. So this is the software we will need to configure all the components of the system. So the MPPT and the inverter charger as well. So it's really convenient to use, really powerful tool. You can use it on your cell phone, you can use it on your computer, and you can connect to the different Victron equipment with Bluetooth. So it's really simple to use. Next one, please. So here you have an illustration of the communication using Bluetooth. So if you want to connect to an inverter charger, so this is what we call V-Bus product. You need the V-Bus smart dongle that will generate the Bluetooth. Or if you connect to an MPPT, if the MPPT is smart, you have already a Bluetooth. And if it's not smart, you can use a Bluetooth dongle. So with your phone, you can configure the complete system. It's really simple to use. Next one, please. Regarding AC coupling system, you will need to install in the inverter charger a special assistant. And for that, you cannot use Victron Connect, you need to use vConfigure. So people used to Victron, they already know this software. So vConfigure, you need a computer to run it, and you need an MK3 to USB interface, so you can connect your inverter charger to your computer. Next one. So what are the different steps to follow when you configure your AC coupled system? We put a link on this slide. We suggest you have a look at it and you read it carefully if you plan to make a system, because you have to check different steps. So there is the system requirement, then the setting of the Multiplus or the Quatro, then you need to implement the frequency shifting and setting up the Fronius as our colleague from Fronius explained how to do it. You need also to check the LAN and network connection, and you need to do some GX configuration if you have a GX device, and VRM portal if you want to remote to do the monitoring of the system. So the GX device and the VRM is optional. The system can work without a GX device, but it's always better to have one, so you have a communication with the system and you have monitoring. Next one, please. First, let's see how to install the assistant in the inverter charger. So as I explained, you need to use the vConfigure software and the MKey3 to USB interface. So you will connect to the inverter charger, and then you need to disable the virtual switch. So by default, the virtual switch is enabled. Then you go in the assistant tab and you will select the assistant called PV support. So this one is the one you need to work to have the inverter charger working with a Fronius inverter in an AC coupling system. So when you have selected the assistant, then you will configure it. So you just have to follow the step, and you will see a window with the different frequencies. So the frequencies that are already set in the system by default are the good one. So you don't need to modify if you use a Fronius inverter because it's already pre-configured. So it's really simple and really straightforward. And then the assistant will ask you as well to inform the power of the PV and the power of the inverter, and then it's done. So when you have the PV support assistant in your Multiplus, then it will manage, it will control the power production of the Fronius inverter through frequency shifting. Next one, please. Also, what you will need to do on the GX device, if you have one, you need to communicate with the you need to communicate to enable the communication between the GX device and the Fronius inverter. So you need to go in the menu, you go to setting, and then you go to PV inverter, and then you have to scan. So there is chances that the Fronius is already visible on the system. If it's not visible, you can press to scan. You can also enable automatic scanning. If you want to add an IP address manually, you can do it. And then when you have enabled the communication between the Fronius and the GX device, then you can go on the inverter, and then you will select the position. So it's really important to do it. Either it is on the AC output, on the AC input. If it's on a phase, you can specify which phase. For example, if you use 3 single-phase Fronius inverter, you will need to specify which phase they are connected on. And these settings you need to do so you have the proper display then on the dashboard. Next one, please. So some comments and discussion regarding AC coupled. So adding a PV inverter to an inverter charger does not increase the system overall inverter size. Why? Because when a large load is switched on, the Fronius inverter will not react immediately. So it means that the inverter charger will need to provide the power from the battery. And so you cannot rely on the power from the Fronius. Also, the solar, the sun is an unpredictable source of energy. So you cannot design the system, the power of the load according to the power of the PV inverter and the inverter charger. So you must need only account the inverter charger in your design. This is something really important to be informed. Next one, please. Also, it has been discussed already before, but we'll give also here an example. So you have to follow the factor 1 rule. So for example, for a small system, if you have a 3-key VM multi, then you can install a 3 kilowatt peak of solar power, or you can install a 3 kilowatt PV inverter Fronius. And as Muhammad said, you can oversize the PV array. So you can have up to 4.5 kilowatt PV array and a 3 kilowatt PV inverter connected on a 3 kilowatt multi, but you should never exceed more than 3 kilowatt. And also, something is really important for bigger system. Also, we advise to work on a lower than the factor 1 rule, probably around like factor 0.8 or 0.75 rule. So, for example, with a big system, a Quatro 90 kVA system, we advise to not exceed 70 kVA, 70 kilowatt for the AC coupled PV power. And so the advice is to go then for if you have more power to install, you use MPT, and it will charge the battery faster and it will stabilize the DC voltage. Next one. So also with our system, we can control an automatic start and stop of the generator. So automatic start and stop is really nice feature because you have a perfect control of your generator, and you can reduce the running time. So you can do it through different ways. So you can do it through the programmable relay of the inverter charger. You can do it through the relay of the Turbo GX or the GX device, or you can do it either through a battery monitoring system, so the BMV. But the preferred solution would be the GX device, because you have a really powerful a tool for that to control the generator. So here you have a screenshot of this tool controlling the generator on the GX device. So you can set up a lot of different features, and you can set up also a lot of different conditions to start and stop the generator. So you can start and stop the generator based on the SOC of the battery, based on the voltage, based on the load, based on the temperature, and you can combine all of them. So if one condition is still here, the generator will keep on working. And you can do also some nice control with quiet hours if you don't want the generator to start too late at night. You can do really, really nice stuff with this tool. Next one. And also something important when you have a system, an hybrid off-grid system with a generator, you have to take care about feeding back power to the generator. So what happened in that case is like you have your generator and you have a large AC load that switches off. So then your PV power is in excess, and if the battery are full, then the PV power will go through the inverter charger, and it can be fed back to the generator. And since the system cannot do a frequency shifting because the generator is providing the frequency and is a grid forming device, then you can have excess PV power flowing back to the generator, which can be really dangerous, and we can also damage the generator. So what we advise in such case is if there is different strategies, but you have to decide based on your design and based on your configuration which one is the best. So obviously do not oversize the PV inverter. Have a really good understanding of your load profile. If you have big load that can switch on and off, you have to be informed of that, and you have to take it into account. Also, what you can do, you can program the frequency of your generator. So for example, some people, what they do, they set the generator to 52 Hertz. So it means when the generator is running, then the PV inverter, the Fronius inverter, will stop producing power. So it's just curtailed. So only the generator will be able to charge the battery and provide the load. Also, another solution could be like to disconnect physically with the contactor the Fronius inverter when the generator is on. Also, some people, what they do, they use the AC output of the inverter charger, and they will program it to be disconnected when the generator is on. So on the AC output, you connect the PV inverter. When the generator is off, AC out2 is connected and with the AC out, and it's providing power to the load. And when the generator is on, then AC out2 is disconnected. So you don't even need an external contactor, and you can do it just through the inverter charger, through programming and through assistance. So this is some warning we would like to we wanted to discuss because it's really important. And I think that's it.
Thank you, Clément.
Yeah, thank you.
Yeah, if there are any further questions on the generators, you guys just contact us and we can send you all the necessary white papers and things around that. Our system, in default, the Multiplus will always look for a clean sine wave, stable voltage from the generator or the grid. So depending on the type of generator that you have, the Multiplus needs to be tweaked to work with the generator giving a weaker energy supply. It's difficult sometimes to have one Multiplus with an external changeover switch working with a grid and then switching over to work with a generator. There's different settings required, and that can be challenging sometimes. And sometimes it means that that generator is just not compatible. But we have lots more information to share with you regarding that. So please make contact with us. So I'm going to go through some of the references training that we have. So here we have a screenshot of our blog. This is a very important part of Victron Energy business. So the first thing, if you guys want to stay up to date with all the latest user stories and application examples, if you log on to the blog over here, you can subscribe. On the top corner here, you can subscribe, put your email address in, and whenever we have a new case study, you'll get an email or you'll get the case study directly to your mailbox. There's various different examples, generator integrated, off-grid. These are some of the latest ones. So yeah, a very important place to find information about user stories from Victron Energy and Victron Energy customers. The second one is our online training. It's linked to our professional portal. The professional portal can be found on our main website. It's a free service to any installer that registers. It's a free registration service. And here you'll find all our training events. So these are live training events. You can see there's one webinar happening on the 14th of April. It's in French. There's some physical events. There's one in Germany. There's one next week in Maputo. I'll be present for that one. There's one in France. There's one in Spain. And these are the live in-person events. So lots of live events happening in Victron Energy. And on the Victron Professional Portal, you'll find all of these. And then we have online events. And last year, we made it available for users to be able to access all the past event videos. So when you log into the Victron Energy training, you have the option of clicking on past events, and all the past events will come up for the last 2 years. You can go and search for all the necessary training that was done in the last 2 years. If you want to update your technical knowledge, it's all there for you to go and view again, download the files, look at the presentation, listen to the comments from the users. It's a very, very nice training resource. And then also linked to the professional portal is our online training academy. And here we have various types of courses. We have some basic courses on the basic products, the color control, Victron remote management, the Multiplus. So here's some examples. There's 3-phase advanced training. There's a lot of theory training. And this is just a snapshot of some of the courses. So if you log into this part of the training, from here you can access all your certificates that you've completed. So yeah, a very nice resource, and this is now also mobile friendly. So you can do all these courses on your mobile phone. You can watch the video. It's a video-based course, and you can do all the questions and answers on your mobile phone to pass and get a certificate. So yeah, a very nice resource for anybody looking to do more training. You can see there's one basic training for introduction to ACPV, which is basically what we covered today. So yeah, very good place to go get some online training. And then we have the online community. This you'll find on the support tab on our website. Under support, you'll go to the bottom. It'll be under tab number 4, the online community. And we have hundreds of thousands of users around the world using our products, and this community is where all the users ask each other questions about applications and products and software and problems, and our community answers most of those questions. We have an interaction of below 10% from Victron R&D staff, salespeople, our owner. We only interact around 10% of all the questions. 90% is covered by all our users around the world. So yeah, it's a fantastic resource to ask specific questions. You can see over here, there's a question about the Own Pilot, which is a Fronius product. And what's very nice is if you come to the top and you type in your question, you would find that once you're halfway through your question, that question could have been asked several times before. So we actually have a statistic for that. And first time, or users asking their question for the first time, that's down to below 15%. So it's you have a 1 in 8 chance of your question being asked for the first time on our community, which is quite nice as well. So you don't have to go think about your question. You can just start typing the product you have and the type of problem, and that question might have been asked before, and there could be several answers for it. So yeah, fantastic resource for all the users of Victron Energy products. And there's a lot of Fronius questions involved as well. You can see Fronius inverter does not appear in the color control, smart meters, zero feeding, lots of different questions. Yeah, we do a lot of Fronius support as well, of course, on this community. And that's the end of our slide. Thank you very much to my Fronius colleagues for the opportunity. And then I'll hand you back over to Cyprian.
Yes, indeed. Thanks a lot, Andre. It was indeed a beautiful presentation. Thanks a lot, Clement. Was also indeed a pleasure having you. And I believe we've done justice to all the questions that have come so far. So just in case there isn't enough time to answer your question, we will indeed do that via email. But then, of course, we'll do our best to answer all the questions in the chat area. On the final note, for all our Sub-Saharan Africa attendees, you can, of course, reach out to us via our contact details as shown on the screen, and we will be more than happy to attend to you. So on behalf of the presentation team today, I would want to thank you all for making our time to attend this webinar, and of course, do enjoy the rest of the day and subsequently the weekend. Thank you and goodbye.
Cyprian?
Yes.
I have just a request just to allow myself and Clement 5 minutes to look through all some of the questions and see if we can answer some of those questions right now.
Sure, indeed. So I will about 5 to 10 minutes per se, and then
yes,
we'll use to answer all the questions, and then afterwards we can now go off.